In today's tutorial, we'll create a RayTK scene that uses an SDF as a field to control the properties of another SDF. This one is more about a technique than creating a fully featured scene, though the result is still pretty neat. We'll be covering topics including SDF-based fields, mapping fields to colors, and expanding and contracting surfaces. There is also a more advanced section at the end, which you can skip if you want, but it will be handy to know about how to create your own variables and selectively apply filters. We'll start by loading RayTK and setting up a renderer. Then we'll create a main SDF shape using a box and a tiled layout. Then we'll create another SDF to use as a modifier. Then we'll use that to control color, and we'll create a wave field based on that same modifier. We'll add a little bit of animation, although that isn't really the focus of the video. And then we get into the advanced stuff where we encounter an issue trying to use our modifier, and we'll try two different solutions, including global positions and creating our own variable, and then we'll finish up. The first step is to load the toolkit talks into your project. I like to do that at the root outside of the main project comp, since that avoids having a lot of confusing data connection lines in the network, but you can put it wherever you want. Head back into project 1, and let's open the RayTK palette with Alt-R. If you have an issue with that, with some sort of NVIDIA overlay showing up, there's a setting on the main component for the keyboard shortcut so you can change it to something else. So type in RayMarch render 3D, and let's create one of those. Then create a null top connected to the first output so you can see the rendered image. And for a preview, I'm going to be using this panel off on the side here just so that things fit well in the frame, but you can either right-click on this top and do View to open up another window, or you could switch on the display flag to show it in the background. If you're curious about this panel setup over here, check out Patreon. There is a template file for that. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. Under Add Camera, choose Look at Camera. Next, we'll create the SDF that will be the main content of our scene. It's going to be a 3D grid of box frames. So let's start by creating a box frame SDF and connecting that to the first input on the renderer. Then I'm just going to organize things a little bit here. Give yourself some room between that and the renderer. To get our repetition, open the palette again, create a modulo 3D, and insert this after the box frame SDF. When we do this, we get this kind of bizarre pattern here, and that's happening because the renderer is getting confused since the box frames are being totally cut off by the slices of the 3D grid, but there's some kind of logic errors in how the rendering handles that situation, which causes this in the background. But the solution to this is to go over to our box frame, and we're going to reduce all three parts of the scale down to around 0.4. Now we can start seeing it there. And then let's drop the thickness down to around 0.05. Currently, the modulo 3D is repeating the shape infinitely along all three axes. Before we start messing with that, though, let's go over to our camera and move it up a bit to around 3. And on the X, let's move it over to around 2 or 3. Then for the FOV angle, bump that all the way up to around 100. Now we can head back over to our modular 3D that's doing the tiling. So the default behavior of this is to tile infinitely along all three axes. What we want is to instead have a limited number of repetitions. To do that, we can change the limit type here from none to both. And then for the limit start, we're going to change all three parts of that up a little bit to around -2. Then for the limit start, change all three parts of that up a bit to -2. And it's good to be actually using that specific value there, not just close to it. Then for the limit stop, we're going to do the same thing, but bring it down to 2 for all three parts. This gives us 5 repetitions along each axis. With that set up, we can create a second SDF that we're going to be using to modify the main one. Open the palette again, and we're going to create a torus SDF, and use this one, not torus grid. On the torus, increase the radius to 2, and let's set the thickness to 0.5. Then let's add some rotation before we combine things. Just create a rotate operator and insert that after the torus. Now we can combine the two SDFs by selecting the modular 3D and the rotate, and open the editor tools menu with Alt-Shift-R. And then under Arrange SDF, not combine, arrange, we're going to choose Simple Union. Then we can connect that up to the first input on the renderer. We're using Arrange here so that we have an easy way to toggle that torus on and off. So if we head back over to the torus on the rotation, we can now try changing that around, and we'll get that moving there. So set this to something that isn't, fully aligned with an axis. Doesn't really matter what the angles are. We're going to add some animation to this later on. Now that we have both the main SDF and the SDF that we're going to be using in the modifier, it's time to start using this to modify the first one. We'll start with color. So create and assign color. Then we're going to insert that after the modular 3D. But rather than just using a single color setting, we're going to create a field that we can use to control it. To do that, select the rotate operator and open the editor tools with Alt-Shift-R, and then select Convert to Float. And this might be a submenu in the future. If so, just use the distance option, the first option. So this gives us a new SDF field operator. Let's then connect that to the second input on the assign color. To make it a little bit easier to see what's going on there, let's go over to our Arrange and just switch off that second input. Now we can see something going on in there, but it's not necessarily what we want. So the default setting on the SDF field operator is distance. So this is a value that will be 0 at the surface of our torus, and then increase as it gets further outside it. And then on the inside, it would go negative. So instead, we can change the field type to inside. So now it produces a field that is 1 on the inside of the torus and 0 outside of it. The reason that things are a little bit hard to see there is because we have those boxes in the front are still there. They're just now assigned black as their surface color. On the SDF field, we have two parameters here that we can use to modify it. First is the offset, which expands it. Let's set that to around 0.4. It doesn't have to be precise. Then for the blending, we can bring that up, and this gives us a smooth transition between the inside and the outside of the shape. So rather than having a hard edge there, we have a little bit of a gradient. Let's set that to around 0.3 or so. Now if we head over to our rotate and try changing that, we're going to see how we are filling that inside area with one color and then the outside with another. But right now it's just using a single value. So this is producing just a single number, and we're treating that as a grayscale color. The reason that you see a little bit of a color in there is that the default material has a little bit of a tint to it, but effectively this is black and white. If we want to go to a color range, or even if you wanted to have the outside be something other than 0 and the inside something other than 1, we need to scale this field to produce color values. So select the SDF field and open the editor tools with Alt-Shift-R, and then choose Map to Color Range, which will create a new color ramp field connected to that. Then we can connect this to the assigned color. Now we can use these two color parameters to define our range. So pick whatever two colors you like. I'm going to go with 0.3 for red and green for the first one to give it kind of like a purple. And then for the second one, just going to drop the blue to like 0.4, give us kind of the yellow. But pick whatever colors you like there. Next, we can use this same modifier SDF to expand and contract the surface of the main shape. Create a round operator and insert that after the assigned color. And then we're going to do something similar. This time we can just use the palette to create the SDF field just for variety. So open the palette and create SDF field. And connect the rotate to the first input. For this one, we're going to keep that default mode of distance, but instead of just using that value as it is or mapping it to a range, we're going to apply a wave to it. So open the palette and create a wave field. And connect the SDF field to the first input, the coordinate input on that, and then connect that to the second input on the round. Things get a little crazy there, so let's drop the amplitude down pretty low to around 0.08 or so. Then you can try using the phase here and changing that, and see how we're getting waves that kind of come out of that torus shape. And if we rotate that to a different direction, it will follow that around. Next, we'll set up a little bit of animation. On the rotate here, select that, open the editor tools with Alt-Shift-R, and then under Animate with Speed, choose Rotate XYZ. And then on the speed generator here, since we're dealing with angles, let's bump up the value multiplier, the first 3 parts, to around 30. And then you can adjust the different speeds on the different axes here however you like, and use the slider, the multiplier here, to control the overall speed. So get that moving however you want. And that's going to be basically it for animation for this one, since that isn't really the focus of this video. This next section is where things get a bit strange. So this is a little bit more of an advanced topic, but it can be a really useful thing to have in your mental toolbox. If you want to keep things simple, you can just skip over this section and go straight to the summary, but I recommend at least checking it out. What we're going to try here is to use this same modifier SDF, and we'll use that to control the scale of the box frame SDF using its scale field input. To make it a little bit easier to see what's going on here, let's switch off our assign colors. So select that, switch off enable, do the same thing for round. Following the pattern from earlier, let's create another SDF field operator, connect it up to the rotate. And then you can try connecting that to the scale field here. On the SDF field, let's change the type to inside. And we're using a separate one here from the one that we're using for colors so that we can have different settings on them. As soon as we connected that, everything disappeared. So what is it that's going on here? There are a few different reasons why that happened. First, we need to give it a more reasonable range of values. So with the SDF field selected, open the editor tools with Alt-Shift-R and select Rescale Field Simple. Then connect the Rescale Float field to the scale input on the box frame. And just going to rearrange things a little bit here, put things in the wrong spot initially. So now that we have our rescale field, we can use the parameters there, the output range, to change the scales that we're going to be using. Let's bring that up a little bit to around 0.4, and now we can see things again. If you try changing the second part of that output range, nothing is going to happen. What that means is that effectively nothing is being considered to be inside the torus. But it worked fine when we did it for color, so what's the difference here? The issue is the modulo 3D. If we go over to that and switch off enable, now we see just a single box frame. As far as the box frame operator is concerned, this is all there is. Even when modulo 3D is switched on, it's still just taking this same slice of space and repeating it a bunch of times. But in any of those, the box frame is always just thinking about it as this one area. Let's go over to our arrange. And on that, you can switch on the second input, and you'll notice that the torus goes nowhere near that shape in the center. And as far as the box frame is concerned, this is what's happening. Doesn't matter which of the cells of the repetition it's in, this is how it sees the world. So let's switch that back off. The goal is to have that modulo 3D repeat that slice of space, but when the box frame tries to use that input to come up with a scale, it should be thinking about the position in space without any tiling happening to it. There are two solutions to that, both of which, in a sense, kind of break the normal rules of how RayTK behaves. Let's switch back on the modulo 3D. The first option that we'll consider is a way to force the field based on that torus SDF to use the global position rather than using the local position that it's getting out of the modulo 3D. So when the modulo 3D produces a cell that's over here, it should actually think of it as being over there and not just, a little tiny world in the center. To do this, we can create an inject global position operator and stick that after the rescale float field. And you could actually stick it on either side, doesn't really matter. So now we're getting something there. Let's go over to the SDF field there, and to make things a little bit easier to see, let's increase the offset to around 0.5 and then blending to around 0.25. So that smooths things out a little. Now we can definitely see that we're getting that torus shape and it's controlling the size of those boxes. This approach is great, but it has some limitations. Let's head back over to the renderer and create a translate operator, and then insert that after the arrange. Once that's done recompiling, try changing the translate here, and you're going to notice how the box frames move, but the torus doesn't. And that's because we told it specifically that it should ignore the local position and always consider global space. And that means ignoring what this translate is doing too. For an interesting comparison, though, we can try switching the assigned color back on, and then going back to the renderer, and on the translate now we try changing it. The color is moving with the box frame, but again, the torus that's controlling that size, the scale, is staying in place. So reset that back to 0 or switch off the enable, and let's explore the other option. What would be even better than using the global position would be to pick an operator somewhere in this chain and take the position as far as that operator is concerned, use it to calculate our torus, and then just use the result of that to control the other stuff. That way, anything transform-wise, including the modulo 3D that happens kind of upstream of that, doesn't have any impact on it since it's already calculated it and set that value aside. And anything downstream will have impact on that since it's being applied to the coordinates that your operator here is getting. The solution to this is to use a variable. Variables are a whole topic of their own, and one of the videos in the intro series covers them in more detail. They're also used a lot in the scene tutorials. The basic idea is that an operator sets aside some information and makes it available to the things that are connected to its inputs. For example, the modulo 3D figures out what cell and row and column and slice within this grid a given point is, and then it makes that information available as a variable so that the box frame could use it for something. You could try to use that value to figure out how to adjust the positioning of the torus, but that's going to get really messy and there's a better option. Instead, we can create our own variable. So open the palette and create a provide variable. Change the name parameter to modifier. And you could use something else if you want, as long as it doesn't have any spaces or weird characters. Then insert that between the arrange and the translate. It's going to take a second to recompile, especially since the scene's getting a little bit larger. Next, we need to tell this operator how it should come up with that modifier. To make this a little bit easier to see, create a null that, and then connect the rotate to it, and then swap that in to connect it to the arrange. Then let's take that null, connect it up to the second input on the provide variable. With this operator in place and now set up there, what happens when the renderer asks about a point in space is that it does its translation, then it comes to the provide variable. That operator first takes this second input, and I know it's a little confusing it's a second input, but that's why this is the advanced section. And it takes the position that it was asked about, which includes the translation, and it uses that to calculate this rotate. Rotate calculates the torus and comes up with a result, and then the provide variable stores that information in a variable. Then it goes on to do the main thing and use its first input, which in this case is our range, which then goes on and does whatever it does. Right now, though, we are creating a variable, but we aren't actually using it anywhere. And at this point, we're now calculating the torus SDF 4 times. So every one of those is going to be adding to performance since we're using that same operator in a bunch of places, which is counterintuitive given how the rest of Touch Designer works, but again, advanced section. With the provide variable selected, open the editor tools with Alt-Shift-R, and under reference variable, choose modifier, and just grab the top part there, not the individual fields. And then let's move this over near our modifier and our main SDF. And we can connect this to that SDF field that's controlling the size instead of directly connecting it to the rotate. And we can also do that for the other 2 SDF fields. Then if we go over to our translate, we try moving that, everything moves together. And we can even use it for the arrange for when we want to be showing that modifier. And you could either wire that up directly, which wouldn't have much of an impact on performance since this operator is just like grabbing a variable, but just to keep the network clean, make a copy of that, paste it, and let's hook that up to the second input on the arrange. And then over on the arrange, you can try toggling that on and off to display it. One caveat of this approach is that you can't use anything to modify the position here. In fact, our inject global position here is being totally ignored, so we can even just remove that. But if you try to insert like a rotate or something else in here, it's not going to do anything because this SDF result has already been calculated, and these operators are just using what that produced. They're not calculating it again, which means they can't look at the result, what the result would be from a different position. And that's it. You can switch the round operator back on if you want, or just leave it as it is and stick with the other 2 modifiers that we have in there. To recap, we are rendering our scene with the RayMarch renderer with a look-at camera. We have a translate in there, but we aren't necessarily using that now, but you can swap something else in there. Then we are setting up our own variable called modifier, which is populated by the SDF result for a modifier, which is applying this rotation and then using a torus. Then the provide variable calls its first input to get the result that comes out of it. So that is the arrange, which will use the first input, which is based on this box frame. The box frame is being controlled, the scale, by a field that's based on that SDF that we had set aside in a variable, which is being mapped to a range of numbers. Then we're applying this assign color to change the surface color, and that's being controlled by another SDF-based field, in this case being mapped to a color range. Then we're expanding and contracting the surface, And again, using another SDF field based on that same modifier. And in this case, we are applying a sine wave to that. And that gives us the ability to have things kind of coming in and out from that surface. This would be another good thing to animate. And that's it. There are a ton of things that you could do with this from here. You could try changing the range of values here. You could even have it be smaller inside the torus and larger outside, or changing the offset here to expand it out, or the blending to smooth out the transition, or try a different shape, or not even use the modular 3D at all. And you could try using a different SDF as your modifier, or different kinds of filters there, or any kind of transform after your provide variable, and that could even include stuff like a modular polar to get a kaleidoscope effect. Anyways, I look forward to seeing what you all do with this one. If you post on social media, use the RayTK hashtag. And at least on Instagram, you can tag me if you want to show off your work. If you want to support RayTK development, subscribe to my Patreon. You'll get access to the Discord community and early access to tutorials and scene file downloads and a bunch of other stuff. And even if you don't want to pay, you can subscribe for free as a way to get announcements about the toolkit. Feel free to reach out if you have questions. I'll put links in the description for that. Thanks for watching, and make sure to like and subscribe.